Okay.
Okay, and we're live. Hey, everybody, welcome to the Audio Programmer Meetup. Great to have you here. There have been a couple months where I've been out of the country or out of town, so haven't been able to hold these as usual. But now we are back, and I'm glad to be here. And um, I go back to Josh. I'm the founder of the Audio Programmer, and I'm here with Luke and Jonas from Reactional Music, and also Matt Gonzalez in California. So today we have a very exciting audio programmer meetup today, and we are going to be talking about a little bit of Juice graphics to start off with. Uh, Matt's going to give us a comprehensive rundown of where we've been, where we are now, and where we're going. And then from there, we're going to switch gears into a world that's a little bit different from what we normally do. So normally the things that we do here are the nuts and bolts of audio programming. And I thought this would be interesting because I heard um, I linked with Reactional Music at Unreal Fest in Seattle, and they showed me what they've been doing with Reactional. I thought it was so exciting, not just for programming, but just for in terms of ideas of where music composition and music and where music and how we create music and how we riff on ideas uh, could could be for the future. So I decided to invite them along because we have so many people here who are from the sound design and composition side of things. And so they're going to be talking about their reactional procedural music system. Uh, Before we get started, I just wanted to thank our sponsors, JetBrains and Focusrite, for sponsoring the Audio Programmer Meetup. So without JetBrains and Focusrite, we wouldn't be able to do this. So thank you to both JetBrains and Focusrite. And just wanted to say this is going to be the last Audio Programmer Meetup of the year. So happy holidays to everybody that's attending today and is watching afterwards. Hope you have a great holiday family, and that we see you in the new year for more audio programming. And with that, we'll go ahead and kick off into our first talk, who's going to be from Matt Gonzalez. And Matt is an independent audio developer with more than 20 years of experience. And Matt also helped to implement the Direct2D graphics for Juice 8. And today he's going to be speaking about the past, present, and future of Juice graphics. So over to you, Matt.
Thank you, Josh. Hi, everybody. Greetings from Southern California. Good afternoon, good evening, and good morning, wherever you are. Josh, could we start by asking how many people have experience with Juice? People in the audience, and what's their level of familiarity? This is kind of targeted towards that, and so it might help to know that. But I'll proceed anyhow while you do that. Let's see. So let's get my screen share going here. So yeah, like Josh said, I'm Matt Gonzalez, and I've been doing this for an embarrassing length of time. Let's see. I've been working for Echo. My PowerPoint go. Yeah. All right. I get my operate computers apparently. I've been doing this really since I was about 14. My dad bought me a Texas Instruments 99 4A with 8K of RAM. And I was pretty excited to get it at the time. And it's really been kind of nonstop ever since. So screen share, there we go. Okay, yeah, so that's me, that's my face. Like I said, I've been writing software since about 1981. I've worked for Echo Digital Audio on and off since 1993. So you can do the math on that, I'm not going to. And I've done a lot of consulting work on the side. At times have been lean, good for the company. I've done pretty extensive work in the pro audio field. If you're old enough, you probably remember the Layla audio interfaces from the late 90s. That was one of the first multi-channel interfaces for a PC. It had a PCI card. I've worked on FireWire, USB. I've worked on plugins. If you can see behind me, there's some red guitars. I don't have my camera on right now, but you can see that. And Those are some prototype self-tuning guitars that we did with Gibson about 15 years ago, if anyone remembers the robot guitar. And I've been a JUCE fan for about as long as there's been JUCE. I think since version 1.5 or something like that. If you look at my forum membership, I've been a forum member since 2005, so I'm a big fan of JUCE. And which kind of brings us to what we're going to talk about today, which is the story of a hobby that just spiraled wildly out of control. I didn't plan to be in this position. The thing that's kind of strange about where I'm at right now, as I was at ADC about a month ago in Bristol, and at the Audio Developer Conference, and I'm walking around, and everyone's asking me about graphics, and I've worked in audio for 30 years, but over there I'm the graphics guy, which is a relatively new development. So it's kind of a fun position to be in, and it's odd to be on the Audio Programmer podcast. This isn't a podcast, right? With the Audio Programmer Meetup, and talking about graphics. But here we are. As a JUCE fan for a long time, as a JUCE user, as a developer who's wanted to build cross-platform audio APIs and UIs and, not APIs, UIs and plugins and things like that, what I really like, I want to be able to build this kind of crazy UI that you see in movies. Like, you see there's all like that's from a James Bond film, right? And I want to have that run full screen. I want to run at the monitor refresh rate, and I want to build it using JUCE, and I want it to be cross-platform. So I want all that stuff. I want, this kind of crazy UI here. This is a bunch of nonsense, right? There's a hexaflexagon process that's running at level 2. There's all these crazy glyphs, these graphs all move around and they animate, and they're great. But I want to build something that looks like this, but really works and is actually useful. That's from The Expanse. That looks like you could pilot it, right, without even trying. That's from the Total Recall remake. But some graphic designer went to a lot of trouble. So I look at that and I think, why can't I build that using my JUCE app? And historically, JUCE has graphics hasn't been JUCE's strong point. I guess I'll put it that way. And I say that with love, and I say that as a fan. And that's the joke I like to say is that JUCE is the strength of JUCE is that it's cross-platform. If you're not familiar with JUCE, JUCE is a C++ library that lets you build plugins and apps using C++, but you can write in a cross-platform manner so that 99% of your code is platform independent. And so the strength of JUCE is that it's cross-platform, and that works really well. And the strength of JUCE is working with audio. It's got all those great DSP routines built in, audio device handling, stuff like that. But the downside of JUCE, I think, is that it's cross-platform. And as far as graphics go, it's really good at audio. So that's been a complaint for a long time from users, is the graphics performance, the UI performance. They've done multiple surveys of their users. And that's the number one request for the last 10 years has been, how do we do better on the GUI performance? And there's been multiple threads on the forum talking about it and that kind of thing. I think it's because most users, up until recently, have been using the JUCE software renderer. And so the JUCE software renderer is part of the JUCE graphics stack. You can see there's the JUCE graphics class. If you've used JUCE at all, you're familiar with that. From your paint handler, that's what you're using to fill rectangles, set clipping regions, set the brush color, stuff like that. That's going to an implementation of the low-level graphics context class. In this case, it's the software renderer implementing, deriving from low-level graphics context. The task of the software renderer is to fill a bitmap, to rasterize a bitmap in CPU memory, which is then passed to the screen using some platform-dependent API. In this case, it's the Graphics Device Interchange API on Windows. But of course, on Mac or Linux or iPhone, it would be different depending on the platform. What we really want, what everyone's been asking for a long time, is cross-platform GPU-based rendering. The graphics layer would still be the same, but now we would have some platform-specific low-level graphics context implementation, which would generate a command list and pass that command list to the GPU, so the GPU rasterizes the texture in the GPU rather than doing it with the CPU, thereby freeing up CPU time and probably getting better quality, too, out of your rendering. That's turned out to be surprisingly hard to do. GPUs are, like it says, they're mainly meant for 3D rendering, and there's some very specific, difficult problems that you want to do in 2D graphics, like stroking paths, like that Bezier spline on the right of the slide there, drawing text, doing very small details. It turns out GPUs suffer. They do everything in groups of 4 pixels, and if you just want to draw something that's less than 1 pixel, the triangle efficiency goes way down. And doing 2D clipping is actually surprisingly difficult on the GPU, especially if you have a complex clipping region. So it's a sense of, GPUs are essentially designed for video games. And so getting 2D graphics to work on you'd think it'd be easier, you'd think it'd be one less, but it's not. And so to dig into that a little more, say you want to go ahead and stroke a path like you've got. That's just a standard JUCE API call, graphics stroke path with this path and with this type of stroke. Something has to happen, and then we end up feeding the 3D rendering pipeline. In that case, it's Direct3D 11, but they all, pretty much work the same way. But that's a fairly complex pipeline. There's a lot going on there. So what has to happen in that middle stage is we need to do a couple of things. And this is, again, from the point of view of, this is about 10 years ago out of date. This is not the way you do it now, but this is the way Direct2D does it. So that's just a little print. I'm sort of time traveling from the year 2014 in this context. But essentially what we have to do is for that path, we have to generate a polygon mesh, just a set of vertices and triangles all interconnected. We have to then draw stuff on that polygon mesh using shaders and textures, and then we have to manage the resources necessary to keep that pipeline flowing. If you spend any time browsing through the JUCE code base, like I have, you'll realize JUCE has had a Direct2D renderer in the code base since 2010 that doesn't work. That's the first commit message I could find. I decided a couple years ago I was going to try and fix it. I was bored. It was COVID. I was locked down. And but I found it wouldn't even build. I started rewriting it about 3 years ago now, I guess. Maybe 4. Yeah, almost 4 years ago. And eventually got it together. That's, I think, more time than I want to spend on it right now. I'd be happy to talk about more about that whole process and getting it together, getting it with the JUCE team, working with them. Eventually it made its way into JUCE 8, but that's another story. But instead, I thought I'd focus today on the technical details of Direct2D, how it works, its limitations. As a developer, how do you interact with it? How can you work with it? And where things might go from here. So I'm going to focus on that. Direct2D essentially works. We wait for a vertical blank notification to come in. We wake up the renderer. We tell Direct2D, begin drawing. Direct2D initializes its internal command batch because its job of the renderer is to build up a list of commands while you're painting and then pass those off to the GPU. We go to the paint handler. In the paint handler, this is where your app is going to run, your plugin, your graphics callback is going to happen. In there, you're going to fill rectangles. You're going to draw circles. You're going to set the color to cyan. You're going to set the clipping region. Eventually, you're done drawing. We call endDraw. endDraw takes that whole command queue, passes it to the GPU. The GPU rasterizes a texture internally. We present that bitmap to the screen, and the cycle continues. Digging into that a little bit more, say again you want to go ahead and stroke this path. We want it to look like it does on the right, and we want it to be nice. We want it to have nice rounded corners. We want it to have a clear contrast, like sharp edges between the blue and the orange there. We want it to look like it's been plotted with a plotter pen tracing a path through space. But for this stuff, the GPU only knows how to make things out of triangles. So what we have to do is we have to take that path and we have to convert it internally to a Direct2D geometry. That happens on the CPU. That's an internal pass. Direct2D, then we take that geometry, we have to transform it to fill the space, whatever, you'll pass it an affine transform, it'll fill the space, rotate it, stretch it, skew it, whatever. We then have to tessellate that geometry, which is turning it into vertices and triangles. And then we have to pass that to the command queue, put it into the command queue to go to the GPU to be transformed, to be rasterized. Tessellation is an old idea. It's the process of fitting shapes together in a pattern with no spaces in between. That is a mosaic, a picture I found of a mosaic in Marrakesh. You can see it's just filled with that regular geometric pattern. So tessellation is an old idea that obviously predates computer graphics. In our case, the GPU needs stuff turned into triangles. It just wants to deal with meshes of triangles. So in this case, that tessellated path turns into a shape like this. And you can see all those little triangles in there. This is a mode you can put the renderer in where it gives you back the triangles rather than painting the path directly. So how are we doing, Joshua? Is that all coming through okay?
Yep, everything's looking great.
Okay, great. Good. So let's switch over for a second here and talk about why bother, why go. I've talked to a lot of users over the last couple of years, a lot of people, a lot of developers, all of whom have come up with their own homebrew, they use the SDL, they use BGFX, they're writing their own OpenGL shaders. They've all come up with their own ways to get more performance out of Juice. They've all come up with their own, everybody's got their own homegrown approach to it. And or some people think the render is fine as it is. We don't need to improve things. There's a lot of opinions, there's a lot of perspectives. Personally, for me, like I said, what I want is I want more performance, and I want things to, and so what's the point of all this? Is it really faster? And so let's take a look at the Juice demo. If you've used Juice at all, then you're familiar with the Juice demo application. And so this is with Juice 8. So let's go look at the graphics demo.
Oh, Matt, I think that you're still stuck on the on the slides there.
Oh, thank you so much. Yeah, let's go switch over to that. Let's go and well, my demo's not working either. So, so what we'll do here is I'm going to pull up some other stuff here that I've got. I'll go to the backup just a second. This will have to pull up some stuff from my my demonstrate the talk I did at ADC.
The demo ghosts.
Yeah. Yeah, exactly. That's the one thing I didn't check right beforehand. Okay, so this is I did this talk as a version of this talk at ADC. So we'll just go back to that. And let's see, it's a screen share. And sorry, everyone. Let's see. Okay. Let's see, where were we now? Of course, it's not there. Resume. This is embarrassing. All right, just a moment, please. I'm sorry. What I'm trying to show is the Juice demo running. You can put it in 2 different modes. You can put it in direct 2D mode or the software renderer mode. And okay, is this gonna work now? What'd you say? The demo gods?
Ghosts.
Ghosts. That's exactly right. Okay. Keep seeing your screen. This is not big. Hang on, can we do the whole thing? This is embarrassing. Let's see.
While Matt's working on that, just wanted to give you a reminder that if you're not part of our Discord community, it's an open invitation to join us. You can join us on our website, theaudioprogram.com/community. Good to go, Matt?
Okay, can we see that?
Yep, it's all good.
Okay, great. Sorry for the trouble. Okay, so this is the, on the left here, we have the software renderer. And on the right, we've got the Direct2D renderer. This is the Juice demo, and I'm going to go ahead and play that. So this is just a video clip, but if running it live, this works this way. And you can see on the left there, the software renderer is getting, excuse me just a moment. Sorry about that. Okay. Sorry. Okay, where was I? Okay, on the left, we've got the software renderer. On the right, we've got Direct2D. And what we have is, you can see on the left that the software renderer is running at about 5 milliseconds. And we're getting a good frame rate. We're getting about 60 FPS on the left. But on the right, you can see there it's about 10 times faster, the actual paint handler time. It's 50 milliseconds instead of 6. That's already pretty good. The software renderer is doing well in this situation. But already we're 10x faster. And if you look at the effective frame rate, you can see the big difference there. When things start to get interesting is when we use this tiled image test. And this is where you tell Juice, take this image and use it as a brush, fill the whole space with this image. And I'm being unkind to the software renderer here. You can see I've got the high quality image interpolation turned on. I'm rotating the image, so the software renderer is having to do all that math to move that image through space, and you can see it's struggling a bit. It's down to about 50 milliseconds a frame. We're getting 16 frames a second. On the right, Direct2D is taking 30 microseconds to render that frame, to execute that command. And it's not even breathing hard. The GPU is not breathing hard. That image is already stored in VRAM, so it's just issuing a single command to the GPU. And so the performance difference in this case, that's when I started to get kind of excited when I saw these kind of performance differences. Okay, back to the other slides. Sorry for all the chaos. I think we're back on track. Okay. One thing that would be, I think it might be of interest to, this is a thing that hasn't really been talked about publicly, is that the JUCE renderer has some pretty extensive metrics built in internally. And if you just set this build flag, if you just set JUCE Direct2D metrics in your app, you can use this here. And if you see here, this is going to find an app. This is a separate app just called the Direct2D metrics app.
Are we supposed to see your screen still?
Are you, is it, oh gosh. This is not, I thought I had it on the full screen mode here. Thank you, Josh. Is that not gonna, how about now?
Yep, we're all good.
Fantastic. Thank you for keeping me honest. All right, try this again. Okay, so on the left, we've got the JUCE demo. On the right, this is the metrics app. And I've got the JUCE demo built with Direct2D metrics enabled. And the metrics app has gone out and what that actually is doing is it's creating a name pipe. There's a server now inside the JUCE app that can report metrics. So you only want to turn this on while you're developing. Obviously, you don't want that in your app running all the time. But you can see here now that I'm reporting all this internal stuff that's going on with all these activities. So this is really helpful for profiling. If you're drawing and you're getting slow performance with your graphics, you can build your app with the metrics turned on, and you can run this metrics app on the right. And from that, you can get a real sense of what's happening inside your frame. Like you can see here that, I'm spending a fair amount of time creating geometries, creating these paths. And this app is going to be available as part of a new module that I'm putting out. I'll be talking about that in a second. Okay, let's get back to the slides. Make sure I'm sharing those. Sorry, this is a little complicated because I'm showing stuff on Mac and on Windows, and it's a little bit of a, there we go. Just share the desktop there, okay. And this is a little rough too. I've only had a few days to put this together, but we'll soldier on and I'll stop apologizing. So let's talk about some of the challenges that we faced with Direct2D. To me, Direct2D has represented a fairly significant paradigm shift for the community and for me and for the JUCE team, really for everyone. Largely because I think we've been used to living with the existing renderer for a long time. We're used to, it's sort of, I think everyone's been sort of living inside the box created, conceptually created by the software renderer. We've been used to that for a while. People are used to working around it. This is sort of how JUCE apps work. And there's kind of a mental shift now because this renderer just works fundamentally differently because all the drawing happens on a different device with a different memory space. We put a lot of effort into backwards compatibility, and we did the best we could, but there were some things that didn't come up during beta, and that's been some of the challenges we've run into. And some of this, I think, was due to limitations in the JUCE object model, where it wasn't necessarily intended for this purpose. And I'm going to diverge for a second. I'm going to talk about the circle ellipse problem, which if there's any C++ developers, you've probably heard of this already if you spent any time reading the C++ FAQ, but I'm going to just review that briefly. So the circle ellipse problem is a classic problem in object-oriented design, and I want to disambiguate a little here because I'm not talking about graphics anymore. I'm not talking about actually painting circles or ellipses on the screen. I'm talking about abstract geometric concepts. I'm talking about the actual idea of a circle versus an ellipse. And the circle ellipse problem has to do with how you take a real world idea, like a circle or an ellipse, and how that maps, how you convert that to an object-oriented hierarchy. And the question is a circle a kind of ellipse? Can you declare a class called an ellipse? An ellipse would have, say, a center position, and it would have an X radius and a Y radius, right? Because an ellipse can be a different width and it's a different height. Can you then say, well, a circle is a special kind of ellipse? Can I have a class called circle derived from ellipse? And if you search for this problem, there's all kinds of people arguing about it in Stack Overflow and places like that. If you read the C++ FAQ, which I agree with, the circle cannot be derived from ellipse because an ellipse can do something that a circle can't do. In other words, the circle can't honor the contract promised by an ellipse. Specifically, if you try to set an X and Y radius for like say the ellipse class as a set size call to set the X radius and the Y radius, The circle can't obey that. The circle can't, because a circle, of course, has to have the same x radius as a y radius. And again, this is the kind of thing, if you read the C++ FAQ, it's really pretty funny because people argue about this all the time. But again, this is how I see it. This is what I agree with. And I think there are two solutions that I know of, which is you make them unrelated classes. So maybe circle and ellipse have similar functions, but they're not derived from each other, or you have them derived from some common base. Whatever minimum common functionality they have is in that base class, rounded shape or whatever. But then the circle and ellipse have different methods going down. And I think in this particular case, what we ran into is we ran into the circle ellipse problem with the JUCE image class. The JUCE image class, the contract with users, it has a few underlying assumptions that people are used to, which is that they can readily access the bitmap data because the bitmap data is just an array of pixel values in the CPU. The bitmap data can be any size because it's just, again, an array just in your CPU RAM. And the bitmap data will persist. It won't just vanish. However, with Direct2D, the performance benefits of storing the image data in VRAM, in the GPU, are enormous. We saw that earlier with the demo. But it violates all those rules. Now the bitmap data is not readily accessible. It's in a different memory space on a different device. You can map the data from the GPU back to the CPU, but that's expensive. It takes several milliseconds, and that really starts to add up in your paint handler. Bitmap sizes are limited to the maximum texture size of the GPU, and that's device specific. And then finally, bitmap data may vanish. GPUs can go away. In one case, imagine you have an external GPU hooked up to your MacBook with a Thunderbolt cable, and that cable gets pulled out. That data is gone. On Windows, if you change the DPI setting for your desktop, the adapter resets. So any data you have in VRAM is gone. And so I think what I've concluded, so there's been some traffic on the forum recently, people talking about this stuff they've run into, and I think fundamentally what I've concluded is it's because it breaks the object model. We've run into the circle ellipse problem. So I think the solutions are to either come up with a new class, like a transient image class, which would be a separate class with a similar API to image, or extend the image to allow GPU storage. And if you're a JUCE user and you've been concerned about this, this is in process right now, and I think it'll be resolved soon. I'd be happy to talk about that more. So that's been one of the challenges we ran into, is that the existing class model didn't map necessarily. And I don't think this is a Direct2D specific question. I think this is a problem that would have happened with any hardware accelerated, any GPU accelerated solution. We would have run into this. Josh, I'd like to stop and take questions now at this point.
Okay, great. So if anybody has any questions, please feel free to put them through to the chat. One question that I had was, what is the Mac equivalent of Direct2D?
Metal. Well, actually, no, I'm sorry. Mac doesn't necessarily have a direct equivalent to Direct2D, in my view. Direct2D is really a software library that sits on top of Direct3D, that sits there and does all the thing that if you saw that one step with the big orange arrow in the middle, it's basically that. And the Mac has a few layers. It's got core animation. Core graphics, I think, is now actually pretty good. Core graphics used to not be GPU accelerated, but the JUCE core graphics renderer is pretty fast. I don't know if there is a strict equivalent that maps quite. The Direct2D mapped almost directly one-to-one to the JUCE low-level graphics context, and I think core graphics does pretty close to that. And I would have said that wasn't accelerated before, but I tried it recently and it was really fast. I don't think there is an equivalent on Linux. And there's core animation, which does some of the things, that does some of the layering. Like a core animation will let you build layers, and it'll let you draw a path in the layer and say, I want to clip to that layer. So my sense is there's different bits of it in different Mac layers. And so I think core graphics is probably the closest you get right now. But I'm not sure there is I actually, well, you're stealing my thunder a little bit, so I'm gonna answer that question more at the end of the talk, if that's okay.
Okay. Another question that I wanted to ask is, working with a legacy API that's been going for so long, has there been any discussion to, okay, what if we just revamp the entire
I,
way?
yeah, I think that's been an ongoing conversation. I think that's been an ongoing conversation for a long time. So my position is a little weird, right? Which is that I'm not a member of the Juice team, right? I float around the periphery of the Juice team. I know those guys, I consider them to be friends, but I'm not an official Juice team member, and I want to be really clear about that. So my opinions are just my own. I'm really just a Juice customer ultimately. I just ended up the planets aligned and there was a harmonic convergence. So the work I was doing as a hobby ended up being something that worked out well for Juice 8. But I'm not any type of official. I think they've talked about that a lot. I think I guess what I'll say is ultimately I've noticed there's no shortage of opinions. That continues to be a rich natural resource that's widely available. And you'll talk to a lot of developers that say, like the guys are talking after me, like you guys are doing WebView stuff, right? You're doing, and that's great. And there's a lot of programmers that want to do WebView, right? They want to do design their plugin in Figma, and they want to use Electron or something like that to do their UI. Bag the whole Juice component framework, great. And they think that's a great idea. And there's a whole other group of people say that's a terrible idea. You should never do that. You'll get, and I don't know if there's a lot of consensus. I think what I have learned is that it's really tough to shift away from the legacy stuff at this point. That was really my experience. Was the expectation was that it would be a drop-in, seamless, frictionless replacement for the previous renderer, and I'm not sure that was possible. I think we could get pretty close. There were some very real challenges too with legacy compatibility. One of which I hadn't even thought of when I started working with these guys was because I was just thinking about Direct2D, I was just thinking about performance, and they said, we need to have Direct2D host a child window that is running the old renderer. And then that child window may in turn have a child window that's running OpenGL. So you had this sort of unholy turducken of Direct2D, which wanted the window set up a certain way so that transparency would work nicely and it would perform with specific window flags. If you set the window up that way, it breaks GDI and it breaks the software renderer. So all of a sudden the child window wouldn't show up. And then, so you had that working, but then the OpenGL window wouldn't show up on top of that. And I finally realized that there was like one window flag we're using where the OpenGL window was hiding behind the software, the plugin window, instead of being in front of it in the Z order. None of this stuff is documented about how it works together. If there's anything, yeah, no, that's fine. Actually, can you just give me like 20 minutes? Because I'm so sorry. Just a moment. Sorry about that.
It's all right.
Roommate. It's none of the stuff is documented to work together or in any way, and it ended up being kind of archaeological. Going back and reading about GDI and stuff like that, you're talking about articles that were in, this is all Windows 95 or earlier, like APIs and stuff like that for Windows. And you go back to that, and those articles are gone. I'm looking through Web Archive and stuff like that to read the MSDN blog posts and things like that. It ended up being kind of archaeological, almost, like getting all this stuff running. So the legacy compatibility was a big issue.
Yeah.
And I think changing the component, yeah, I think maybe extending it is something that may happen. That's something which actually we did get that with some of this stuff. Like right now, you can do GPU accelerated effects with images. You couldn't do that before, and that kind of thing. Hopefully that answered your question.
Yeah, it does. It actually brought me to another question, which was relating to web views versus native C++ rendering. So in my limited research, my understanding is that you will never even if you're using WebGL, you're not going to get the type of performance that you're going to get from.
I'd say that's any type of cross-platform layer, including Juice. You're going through a translation, and that's gonna impede performance. I think that's always. I think it's compromises, right? It's everything is trade-offs in engineering is what I've found. I think you can get I haven't worked much with web GPU, but I understand you can get good performance with it. There's a project running in Rust right now called Velo. That's there's a researcher at Google who's doing some really cutting edge research. It's really cool, and it's all GPU, all the render running entirely in the GPU for Rust rendering, and that's all through WebGPU because they want it to be cross-platform and they want to just write their shaders once. But I think even if you read their repository, you read their discussions and that kind of thing, there's a reluctant admission that, yeah, we probably will have to have a native interface. We probably can't get everything through WebGPU because WebGPU doesn't have the feature set we need. And it's always a trade-off. For example, if you want to do this say you want to write cross-platform image effects or cross-platform audio rendering, right? It'd be nice to just write that shader once. But on Windows, you've got the high-level shader language. You've got and HLSL, whatever that's called. You've got the OpenGL has its own shader language. Metal has its own shader language, and there's not really there's no C++ for shaders unless you just write them once across everything. Yeah.
Okay. Doesn't look like we have any other questions, so feel free to continue on.
I'm crushing it. All right. Okay. Let's see. So the next section of my talk is kind of more for fun. And we're going to talk about Mescal, which is a new module that I'm putting together. And one of the things I'm trying to gauge is the level of community interest in this, but it's basically bonus direct 2D features that didn't make it into the JUCE library. They weren't really a good fit, but there were a bunch of direct 2D features that I thought were fun and that it'd be nice if people had access to them. It'd be nice if I had access to them. So this is a library that builds on top of JUCE 8 that gives you some more fun things. And as tradition dictates, any JUCE-related project has to have an acronym that's has your name in it, like JUCE itself, or there's been everyone else that comes up. And so that's my silly forced acronym name for the module. Plus, I just like Mescal. So let me see here. I'm not screen sharing, right? So let me get my screen share switched over. And this also speaks to the problem that we have is that we've just sort of been living in the box, that I find that we aren't necessarily used to being able to do new things. For example, a lot of JUCE developers that I talk to have never heard of a mesh gradient. I hadn't either before all this. Is that coming through?
Yep, all good.
Oh, and the screen sizing's wrong. You can see down there it says direct 2D bonus features for JUCE 8. But if hopefully it's what's coming through in the screen share, it might be kind of blocky. The video compression tends to play a number on this kind of thing. But hopefully you can see the colors cycling in a sort of two-dimensional way. You can see them moving left to right, but they're also moving up and down. And that's a mesh gradient. Normally the gradients, the JUCE supports linear gradients and radial gradients. So a linear gradient will just go along a line from point A to point B. A radial gradient comes out from a center radius and moves out in a circular fashion. This is a grid of vertices where each vertex can be a different color. And it allows for these sort of elaborate kind of, trippy background sort of abstract patterns, or a lot of things actually. Let me give a more concrete example. That's coming through okay?
Yep, that's all good.
Great. Okay, so here, this is a mesh gradient made with a single patch. A patch is this kind of shape. It's got four corners, four vertices at the corners, and each side is a Bezier curve. And then there's these interior control points. This is a little harder to see maybe, but this is kind of showing how the colors are distributed. Let me change the color of that vertex so we can make it a little clearer. This is changing kind of how the colors are distributed across. This doesn't always come through visually in the most obvious way, but it changes the kind of the mixing of the colors within there. So all these here, right, we can change this. We can, if you start messing with it, you can make a sort of round shape. And so there's a lot of, it's very flexible, the things you can do. So you can imagine it doesn't have to be a square. It could be a blob. It could be a circle. It could be an ellipse. There's a lot of things you could do with it. Mesh gradients can be formed out of multiple patches. So I'm going to add some more patches here. I'll add that there. And now you can see that we've got a, you can see that we've got a 3x3 grid, each with its own control points for each patch. I can change this color here now, and that'll change all the colors for all the surrounding patches because they're all linked together. They don't have to be linked. The patches can be discrete as well. So you can get these really interesting, elaborate patterns that come across here. So then you can pull this point around. You can change how the colors are distributed. It's a design element that I feel like I see a lot online now. It's just as backgrounds and things like that. And it's a new feature that you couldn't do with JUCE, and now with this new module, you can do that, at least on top of Direct2D. So another one we've got is one of the things you can do with these mesh gradients is you can bend and torture them and get a conic gradient if you split them up properly. So this is a mesh gradient that's had its math set up just so that the patches, each one, there's a patch that's going right here. You see each of these stopping points? That's a patch right there that's kind of shaped like that. And then,
What's your screen again?
oh, Josh, thank you, Josh. I get so caught up in what I'm doing. All right. There we go. Okay, there we are. So this is a conic gradient, and this is a mesh gradient that's been bent into a particular shape. And each of these, the patches that I was showing before, that's each of these colors. You can see here, I don't know if, again, this is coming through with the video encoding, but in the screen share, but those are moving a little bit. Let's try, let's say a different color. So that's the HSV color wheel. And you can see now, so this is, again, like you can imagine, what could you do with this? You could do like a radial slider, like some type of radio graphics display. But hopefully what's coming through is that the colors are moving in a sort of a path around the center here, which again, you can't do with any of the existing gradients in this here. You can go and you can set the size, that sort of thing. So that's another new feature. Direct2D also has a lot of built-in image processing effects. And again, this is all about getting things caught up from, like your iPhone, your Instagram can do image filters and stuff like that, right? You can do, you can make things black and white or sepia toned or posterize them and stuff like that. But that's all running on the GPU on the phone. So really some of this is just catching us up to the state of the art or to what everything else can do. For example, here's a demo of a real-time effect running in a shader in the GPU. And there's just a simple slider here to show the amount of blur. That's coming through, right? I'm not being, that's good. Okay. And so that's, a Direct2D has a whole bunch of different effects that are all built in. You can do more complex graphs. The nice thing about the effects is you can chain them up together. For example, this is my attempt to build a sort of three-dimensional button. And I think what people have traditionally done is they have taken, they've gone to Photoshop, they've gone to Figma or whatever, and they've generated all the different states of their controls as bitmap, have those as a great big bitmap atlas, and they pluck out the one bit that they need to draw the slider at a particular position. And one of the things I'd like to be able to do is do that procedurally. I'd like to be able to draw the control at a particular position, have it be nicely shadowed and shaded and filled in. And so this is my attempt on the left at a 3D button that's been pushed down. And on the right here, this is the effect graph that it took to do that. These effect graphs work a lot like audio plugin graphs, where you can feed an image, you can feed a plugin into another plugin. They're essentially just plugins. And so for example, here, I've taken this rounded rectangle, filled in with a gradient. That's just a standard JUCE API call, nothing special there. I've taken the shadow, I've transformed the shadow, and I'm compositing that with the original image. And now you get a nice kind of drop shadow underneath there. So now that's already looking more three-dimensional. Direct3D has an embossing effect. So I've taken that a different shape, a different rounded rectangle, a little bit smaller, fed it through the embossing to get that pushed in, kind of, pressed into the screen look. I'm using a chroma key effect to snip off this gray background that's around the outside. And ultimately, all that's getting blended together to give me that kind of 3D looking button there. And the code for this is pretty simple. You can just create these objects. The objects have properties, and you can just stream them together. You just say, feed this one as an input to the next, and it's the actual code ends up being very compact. And let's see, if we go in here, each of these effects has properties, which aren't showing up. Okay, cool. We're not going to do that part of the demo. The demo of Ghost Strike again. Each of these has a set of properties that you can pull up. You can set the shadow color, you can set the affine transform, and there's a straightforward. And what the new module is offering is the ability to, there we are. Obviously one or two bugs to fix there. What the new module is offering is the ability to do all that in a very sort of JUCE-friendly way. So you configure the gradients with the JUCE color object, with JUCE rectangles and that kind of thing. So it all looks very familiar, and it all builds nicely on top of that. I think we've covered just about everything. Putting all that together, I thought it'd be fun to take a slider. Let's see if this actually is going to run. Well, maybe not. Okay, well, we'll skip that. Again, the demo guides. I think this is because I'm running it on my Unparallels on the Mac. Of course, it worked on my PC this morning. So the snag with this is, of course, all that only runs on Windows. And that's the question I think you were getting at earlier, Josh, which is and that's the question I always get as soon as I show people this module. It's like, well, okay, that's a really good point. I'm a JUCE programmer. I want to write cross-platform code. So how do I do that? And that's something I've given a lot of thought to. In fact, I guess ultimately what I've concluded, and this is kind of getting us, we're just going to jump to the next portion of the talk here, is that Direct2D is really just a stepping stone. Let me get back to the share here. Direct2D is out of date. Direct2D is Windows 8 era technology. So it's 10 years out of date. So the irony is we have gone from Windows 95 era rendering to Windows 8 era rendering, meaning we're just 10 years behind. That's an improvement. And you can see there's just sort of a brief history of what we've done. GDI that we're using for Windows really dates back to Windows 1.0, which is from the 80s. And so we're easily 30 years out of date there. We talked about graphics card, we'll skip that. And Josh, you were asking about what's the equivalent of Direct2D on the Mac? And you got to think about Linux as well. And I guess ultimately what I've concluded is, even if it was there, I wouldn't want to use it. What I'd like to do, what I hope to do, is to skip all that and go as low level as you can. I thought the point you raised earlier about web GPU was really good, because ultimately, if you want the best performance, if you want to build that crazy complex UI, you need to go down to the hardware level. You need to skip any type of translation layer. And so I'd like to move everything into the GPU. That would be my dream. It was to take all this, build a little graphics context that uses all of the modern GPU features, that catches us up from the last 10 years of graphics technology, offloads the CPU, unclogs the message thread, uses all these new features, and really takes it to the next level. That's my dream. And I've spent a fair amount of time thinking about this. This is everything a JUCE low-level graphics context can do. It's maybe a little too small on the screen share, but really it just does like 5 categories of things. That's not that many function calls if you look at it. There's 5 clipping operations you can do, 2 transform operations. There's 10, 12 drawing and filling operations. You got a couple of brush things you can do. So if you can do all that, you can build a better renderer. And to do that, you're going to have to get into shaders. And that's the thing I've really been learning about in the last few months. And again, I'm not an expert at this stuff. I'm still a student. I'm learning. I'm probably going to say something inaccurate. Feel free to correct me. But what I have learned is that shaders are really just little functions that run on the GPU. And I'm not sure what everyone's level of expertise is with this stuff. Someone probably out there knows more than I do, and I'm probably going to say something wrong, and feel free to message me on Discord or whatever. But fundamentally, what it comes down to is, if you're used to writing CPU code, right? If you wanted to process a bitmap, you'd have one, for x equals 0 to the width, for y equals 0 to the height process, and then eventually you're done. And that would all run in a single thread. Maybe if you work really hard, you'd split it into a couple of threads into a thread pool, and they'd all come back together at the end. With the GPU shader, you just have to get used to the idea that you have thousands of cores. You're running thousands of threads at the same time. Maybe they're sequential and stuff like that, but you have to get the idea that you're basically processing, you're going to bring a function that's just going to process 1 pixel, and it's all being divided, and it's all happening at the same time. And it's a really fundamental shift to really get your head around. It's really tough. Shaders, there's different types of shaders. There's vertex shaders that can, basically where you pass the mesh. That's what Direct2D does. There's a vertex shader for Direct2D that's going to accept that mesh from Direct2D. The fragment shader colors in the triangles. Compute shaders are what you've probably heard, that's what you use to mine cryptocurrency and for all those effect images. Those are random compute shaders that I showed earlier. But there's new types of shaders. There's an object shader, sometimes called an amplification shader, that just can take generic objects and create mesh shaders. But the one that I'm really excited about is the idea of a mesh shader, because a mesh shader can create geometry. The mesh shader basically replaces the vertex shader and lets you create the geometry, and that opens up all kinds of possibilities. This is an illustration of how shaders are organized. They come in either a 1D, 2D, or 3D grid. They're groups that make up a grid together. And so a lot of the thinking you have to do with shaders is figuring out, how am I going to organize this grid? How am I going to divide things up? And again, it's a huge, if you're used to CPU-based processing, it's a huge change in your thinking. So a big part of it is figuring out how I'm going to organize it. That's just to dig into it a little more. Say I wanted to draw a rectangle. The software rectangle, I would just be sitting there going through the loop, rasterizing it, the double for loop. I'd be filling in the pixels, trying to do some anti-aliasing. With Direct2D, I'm going to have to take that rectangle and I'm going to create 4 vertices that make up 2 triangles, like that illustration on the right. I'm going to transform that rectangle, whatever transforms pass through the renderer. I'm going to pass that mesh to the vertex shader. It's a very simple mesh of 2 triangles, but the vertex shader will take that, transform it into the coordinate space of the GPU, and ultimately it gets painted by the fragment shader. What I'd like to happen is I'd like to not generate that geometry on the CPU. What I want to do is I want to generate the geometry on the GPU. I want to have as little overhead on the CPU side as possible, which means I just want to pass a command to say, draw a rectangle to the GPU object shader. The object shader would then, there'd be, so 1 thread per one of those shapes that I want to draw. It then spawns off 4 mesh threads. So there's a grid of, this is hard to explain, but there's a grid that then spawns multiple grids. And each of those mesh shaders generates the vertices and the triangles, which then gets colored by the shader. In other words, the whole computational load of all of that stuff that has to happen. And if that's just 1 rectangle, that's no big deal. But if it's tens of thousands of rectangles, that starts to get interesting. So that being said, what we got here is this is a prototype metal renderer running on the Mac, doing exactly what I was describing just now. And so this is what I was referring to earlier, Josh. I don't know what the equivalent of is on Direct2D on the Mac. Not sure there is one, and I sort of don't care because I want to go past that. I want to just jump over it, and I want to go right to metal. I want to basically, my goal is, you can see here, there's a lot of it's running already. This is just an engineering demo. It's just a prototype. It's not the real thing. There's a ton of work to be done on it. But over here, we're filling rectangles. We're filling a rectangle list. It's drawing rectangles. It's drawing ellipses and circles. There's some paths being filled and stroked here, and it's doing text. The image rendering isn't working. I don't know why yet. Right now, it's about 4 to 5 times as fast as the core graphics renderer, and I think it could actually be considerably faster. And the thing that I think is really exciting about this as much as anything is not only do you get better graphics performance this way, not only are you offloading the message thread, not only are you freeing up CPU time for your signal processing and stuff like that, this lets you access the GPU. This lets you as a developer start thinking about, you can write your own shaders. You can access the absolutely massive amount of computing power that's inside the GPU. You can start writing your own image effects and stuff like that. It opens up a whole new world of computing power that you haven't had access up until now as a JUCE user. And that's what really excites me. So this is very much early days. I've only had this running recently, and it needs a lot of work to really be a full-fledged usable thing. Taking all the lessons we learned from doing Direct2D and realizing, what people actually need and how this should actually work. But yeah, that's this is where I think it should go. And all of these ideas could be ported back to DirectX 12. They could be ported back to Vulkan. In other words, you could have this architecture on every platform across everything. And it's something I'm actually pretty excited about. I've been working on it, and the more I've looked at it, the more excited I get, the better I think it can be. I think that's about all I had. That's my contact info, and Josh, I'd be happy to take questions now.
Yeah, so I have another question. So in terms of your vision of how the metal renderer and then porting it back to a Windows compatible equivalent, how, in your vision, how would that manifest itself in terms of what the developer is actually coding in? Because I've heard that actually drawing using, I don't know what the proper terminology is, but drawing in metal is actually quite difficult or has a steep learning curve. So would that be a C++ abstraction, or how would that work?
So you would be hidden from it. It's okay. So that's a really good question. Let's look at the code. Okay, yeah. It's a low level graphics context implementation. So that app I was just showing you, all that drawing that was happening. Let's pull that up. That was all just stock JUCE code. Everything that's happening there.
Okay, interesting.
So that's the point of all of this. It's the same thing with Direct2D, right? Which is, where are we? Here's the code. There's a bunch of commented out code that no one wants to see, right? So this is just my paint handler. This is a class called Painter that's just taking a JUCE graphics object and an area, and it's just got a little bit of timing information there. But all I'm doing, this is doing the metal drawing here, right? So this is like, so what I'm drawing a red rectangle, here's an orange rectangle, here's a rectangle list in yellow, right here. And down here, what am I doing? I'm drawing an outline of a rectangle and I'm kind of oscillating the thickness based on the animation time. And here we're filling an ellipse. And here I'm drawing an ellipse in indigo. And then down here, I'm drawing text, the quick brown fox jumps over the lazy dog, right? So this is all just stock JUCE graphics calls.
Got it. So you're
Right.
just suggesting that they just change what happens
Well, that's how
below.
Direct2D works, right? Is if we look at the graphics stack here, and then how do I do this? Right? It's just so you have a no, that's not the right shape. Let's do one of these. Okay. Yeah. Worst thing to do live. Why isn't? Yeah. Okay, there we go. So if this is your component, right? And then your paint handler, you're talking to the JUCE graphics class, right? Everybody's used that, has used JUCE, right? Below the JUCE graphics class is the low-level graphics context. And this is going to be different depending on each platform, the LLGC, right? This is going to be core graphics, maybe. It's going to be Direct2D, it might be GDI, it might be something like that, right? This would just be a metal level graphics context.
Right.
So your layer up here at the top, unchanged.
Right.
Now, with the caveat that the stuff I talked about earlier, that with the difficulties with the object model and the fact that a GPU-based renderer doesn't necessarily fit into the existing model, and then we've got to tweak that because of that whole circle ellipse thing. But that would be true of any GPU-based renderer. But fundamentally, if you just want to draw text, if you just want to fill a rectangle, that kind of thing, fill in the background as orange, it's exactly the same.
Right. So you're just suggesting to use the GPU no matter what you're drawing.
Yeah, what I'm suggesting is replacing this layer here. Is the low-level graphics context down there. That's that. I feel like I may not have explained that very well. Yeah. I guess if you say, stroke a path, what normally happens, right? That generates, the CPU starts rasterizing that. And I guess, yeah, I'm suggesting that all of that could be moved into the GPU with no intervention on the part of the CPU.
Right.
Without all those, like, we were talking earlier about web GPU and the performance issues and that kind of thing, because of the necessary translation. I'm saying essentially we move all the translation into the GPU and all the mesh generation and all the rasterization into the GPU. It essentially offload it completely and free the GPU app. I was originally contemplating some type of threading scheme where you with Direct2D, where you build up a bunch of threads, you build up a bunch of commands in your paint handler, and then that gets pushed off to a thread. Like, for instance, that's how Firefox works. But let's not even do that. Let's just dump it all. Just get rid of it all. Don't do any rendering on the CPU. It's the wrong tool for the job.
You were saying that the problem with that was that one of the requirements was that you have a regular component that could host any other different types of components, like an OpenGL component.
That was an issue with Direct2D. Yeah,
Right.
Yeah, that's and I think in retrospect, if I had it to do over again, I would have made Direct2D. I would have suggested that it isn't my call, but one other approach we could have taken that might have been better. Like with OpenGL, there's the OpenGL attachment in JUCE that you put in your component. Like you instantiate this one thing and then you just get OpenGL rendering. So it's opt-in to OpenGL. Direct2D could have worked that way too. Direct2D could have been an opt-in attachment that you put in your class, and then everything got faster. But the software render, maybe that should have been the default. It's hard to say. There's an argument to be made that would have been better, and I think that might be the approach. That's what I've got now with that new app, is that the metal is an attachment that you put in your component, and then it actually creates a child window inside there, and it's actually rendering everything in metal inside that child window, which is seamless to you. You don't notice anything. That all happens under the hood.
Got it. So you could opt in or opt out per component.
Yeah, by just creating like a metal attachment in your, as part of your component. You should have a metal attachment member variable in your class. And that's literally all you'd have to do. And so yeah, so ultimately, the goal is as much as possible, given the limitations of the object module, to have it so that you just drop this in and all the rendering moves to the GPU. And we're not quite there yet, but that's I think is that's the ultimate final form of the whole thing.
Yeah, love that.
Oh, we'll see.
So there was a comment from Revolt DSP that says, I render out my shaders and textures on Blender, then skin the
Mhm,
plugin with images. GPU render for C++ would open
mhm.
so many possibilities.
Rock and roll.
Cool. I think that's everything that we have for everybody that we have for questions. Matt, thanks so much. That's really
Okay,
awesome.
I think I went a little over. Sorry about that.
Oh, that's all right.
Sorry for the chaos. It was a bit of a last minute faff. Thank you very much. Thank you for having me.
Thank you so much, Matt. All right. So just a reminder before we move to the next talk that we wanted to thank our sponsors, Focusrite and JetBrains, for sponsoring the audio programmer meetup. And if you want to connect and learn more about audio programming, be sure to join our community over at theaudioprogrammer.com/community. Matt is over there under the name Truckosaurus. So you can connect with Matt there, and there are so many other people that you can connect with as well. Oh, we do have one more question, Matt, from Revolt DSP, asking where they can find out more about Metal, the Metal API.
Um, there's a really good website called metalbyexample.com that has really good tutorials, and I really rely. He does, I think, a better job than the Apple documentation is a bit of a mix of some of the important information is actually buried in the sample apps, not the documentation itself. And the Metal by Example guy does a really good job. It's been around and he just did a sort of retrospective on from scratch about how do you write a Metal app from beginning to end. Metal is pretty user friendly, I found. Like there's a oh, I'm gonna hijack your meeting here for a second, Josh. There's a good example here on just called Hello Triangle. That's probably the best. That's where I started. And where's my Xcode? Oh my gosh, every single time. All right, there we go. And so they've got a really nice example. Like here's all the shaders, for instance. Just in the oh no, that's not the shaders. That's the shaders. So for example, here's the vertex shader, and you can see that that's just a really simple example here. And here's the fragment shader. They've got a renderer set up that creates the shaders, instantiates them, shows you how to talk to them, show you how to pass parameters to them, and it just gives you a nice kind of simple. It's a nice simple example. It's taking forever to come up. Go ahead and message me on Discord if you want to talk more. Josh, is there going to be some place we can post, links and that kind of thing afterwards? Or are you just going to put up people's contact info at the end?
Yeah, I'll put people's contact info within the video description.
Perfect.
And
Yeah,
then, yeah, feel free. Happy to put it also in the video in the announcement on Discord for
great.
our next
Yeah.
meetup.
Yeah, but hit me up on Discord. We can talk about it more. There's yeah, metal's really cool, and
Yeah,
yeah, this stuff's a lot of fun.
I love that. Yeah, thanks so much, Matt.
Thank you, Matt.
Cool. So thanks so much to Matt for that. And now we're going to go ahead and switch gears and go with something that's a little bit different from what we've done in the past on the audio programmer meetup. So many of us come from music composition, musicians. I come from a DJing background. There are people that come from the game audio world, sound design. And a few months ago, Jonas and Luke and I met initially at Unreal Fest in Seattle, which was a game audio for Unreal Engine, or a game conference for Unreal Engine. And I was so fascinated by what they were doing, and it gave me so many different ideas that we wanted to get them on the channel just so to help spur on ideas and help talk about the awesome things that they were doing. So thought it'd be great just to get them on here. So Reactional is a procedural music system for game audio, and I can see so many other uses for this as well. And they're going to be talking about their engine and the work they've been doing and their API and their vision for the future of game audio. And so with that, I'll go ahead and pass the virtual mic over to Jonas and Luke.
Thank you so much. Firstly, I'd like to introduce Luke Ritchie. He's a huge player in our team, doing all of the biz stuff that we don't want to do, but he does it in stride. So would you tell us some more about yourself, Luke?
Yeah, I'm not going to talk much on this session, but yeah, I've worked with Reactional for 3 years, and yeah, I'm on the business development, customer facing side of things. My background's in music. I'm a musician, but worked in tech for a long time. I actually worked at the Philharmonia Orchestra in London and did some work for the San Francisco Symphony. Did a lot of work in music, and we were doing more and more projects in game engine, starting in VR, going into real-time projects with Epic Games and other partners. And I just realized that had massive implications for composition. And that's how I met Jonas. We did a project together with a bunch of partners. And I just got really excited about the concept of composable procedural music, and the idea of how we can compose music for interactive landscapes. So I can jump in later if needs be, but I'm going to hand back to Jonas and he can take it away.
Don't I get an intro, Luke?
I'm going to let you do that. You'll do it better than me.
Sure. Okay. So I am from Sweden. It's very cold here today, and looks much nicer over at Matt's. And yeah, I am originally a composer. I studied electroacoustic composition, and whilst doing that, I did a lot of fun projects and prototypes with Max MSP and later Super Collider. My pride and joy from that period was this installation where I had a depth camera that would analyze your face and then measure it according to the golden ratio, and then generate a piece of music based on how ugly you were compared to the beauty standards. So that was fun. But after graduating, I realized making a living doing sound installations and very strange electronic music is hard. So that's why I started composing for games. And after having done that for a bit, I also started doing implementation in the game engines for sound design and game audio, and building fun little systems in the engines, designing music systems. And then, of course, I met one of the other founders, Jesper, who had invented this compositional iPad app where you would input a lot of musical rules, and then you could via your fingers perform on these rules and generate music materials. And whilst we worked on the second version of this app, I started badgering him and the others in the team to let's move into games. Like, games is cool, everybody loves games, but they don't love games. So they said, no, games is not for us. But then we met some potential investors, and they said, have you looked into games? There's a lot of money in games. So then we started doing games. Yeah, so we started redesign our music tech to then be a procedural playback system for games. And I guess the reason for doing so, like, I'm actually going to show you this slide from when we met Joshua, describing the interactive music history. Here we go. So this is a graph that I made up. So it's kind of true, I think. But back in early video game, music was being generated on the hardware via chip. Eventually, we got these Sound Blaster cards, or sound cards that had, general MIDI sound banks built into them, and then suddenly the games would play back music through those sound sets. But in all of this period, music was actually being generated on the fly as the game was playing. then the big bad wolf of CD-ROM audio happened. So suddenly you could have fancy recorded music in your games. And suddenly we lost all of the potential interactivity that we had before. There were some systems, iMuse from LucasArts, for instance, that MIDI-based, played note by note, and it could, interpolate between different states and stuff. But all of that was lost because of CD-ROM audio. And then, of course, the way that game music is done today and has been for at least 25 years is that you have stems exported as loops, and then you switch between these different loop sections or fade up and down stems. And it's a bit ironic because like the rest of video game technology has made these massive leaps since then, but we're still playing back loops over and over, playing back loops. So we figured that, do we really need to have realistic physics for eyelashes and hair that moves naturally when we're still doing loops in music? So that's why we then started doing the Reactional music system. So Unreal is actually kind of championing procedural audio at the moment. So they have a timing system called Quartz, which lets you finally play back sound sample accurately, which like up until that point, I did some games in Unreal and I tried to have music systems where even stems would play in sync together, but they would always drift eventually because you couldn't schedule the changes. But now we can actually do that. And then they made this thing called meta sound, which is basically max MSP, but running in Unreal. And it's super cool. So I wish that existed when I was studying and doing my fun installations, because then instead of going via max MSP or Super Collider and then piping everything via, say, open frameworks or processing for graphics, you could do everything in Unreal these days. Now, we talked about the reasons for doing note by note, and that is what this slide before here said, that sonically music in games is great today, but it's not interactive at all. So I think I'll jump into some live demoing. We have a set of tools. Of course, we have plugins for game engines. Currently Unreal and Unity, but soon launching a Godot plugin as well. Our engine also runs in the browser via WebAssembly, and it's a kind of small library written in C, but the tools around it sort of are responsible for front end and similar things. So here is a session of a composition that I composed in Reaper, one of the DAWs that we support. In game audio, everybody loves Reaper. I'm not sure how prominent it is in music production or in your field, Joshua, but
Everybody loves it.
everybody loves it. Yeah, awesome. Yeah, I love Reaper as well. So as such, Reaper was the first DAW that we supported, and I'm going to play you a short snippet here. Is that coming through?
Yep.
Yeah, so a generic run-of-the-mill, it's very exciting action sequence. Now, one of the other things that we really wanted to, or I really wanted to get away from as a games composer, was the endless exporting of all these assets, like all these loops and stems and whatnot. And of course, in Reaper, you can do a batch render script for all of that stuff, which is great in all. But then you still need to put it into a middleware or inside the game engines and hook everything up, and that takes ages as well. And if you need to change something, you need to redo everything again. So with our system, you drag and drop your actual DAW session into our authoring tool called Reactional Composer. So we'll do that now, actually. Bloop. And then it renders everything needed for note-by-note playback inside our system, and that takes around 30-40 seconds or so. So we do that by parsing the Reaper session and getting everything that we need in terms of MIDI and settings and whatnot. And then we have our own headless little audio system running in the background, rendering everything. So in order for this to actually import, what's important is that we rely on naming schemes. So for instance, this one is prepended by performer. If I were to remove that thing, then this instrument would not be accounted for. What's going on here? And likewise goes for these regions. If they're called part, colon, something, then we'll bring them into the system as well. There's also a concept of stingers, which is just a very short musical frame, a phrase or a chord or something that generally in a video game you would have, like when an exciting hit happens, then you bring on some big horns or a taiko drum or something. Now, let's go into Reactional Composer then. So it is a MIDI-based playback solution. We need the composers to use VST3 instruments for this all to work. And now in here we can start designing these interactive macros, we call them. And we can name them to something cool. And then we can start adding these MIDI effects to this session. So we'll drop some of them in here. And we can, of course, do complex plugin chains where this value will affect the different plugins independently. But for showcasing this is simpler. Let's see, let's do one of those maybe. A velocity maybe we can have as well. Transpose. So in a minute I'll play this back, and when I am moving these around, then you'll hear how the music adapts. And of course you see this list of names here. These are the instruments in my session, and I can also then target only specific instruments if I want to. Fingers crossed, no demo ghosts. Let's hit play. And it works. How's the volume? Can you hear me?
It's good. Yeah.
It's good, yeah. So the most obvious thing is to control the tempo of the music. And I mean, for music producers and composers, that's like, okay, so you control the tempo, but in game music, you can't control tempo. It's ridiculous. You have loops, so you're stuck with the tempo. We can also mess with the rhythm, of course. So here's a swing effect. It's pretty neat. This one will randomly push the onset of certain instruments. You get these rhythmic variances. Makes it move a bit. A note probability, so guess you could figure that out by the name. So you can scale back the music. And then it's exciting again. And this was just velocity. But the most fun bits is when you start to mess with the harmonic content. So here we have a plugin that does modal transposition. So with very little means, we can have something that starts to sound quite different from the starting point. I like this combo because it sounds like Enya, and growing up my mom would always play Enya. Let's bring this back up here. Now, since these are all like sampler instruments, or since playing back live inside the game, we can also override these instruments at any point and have the game developer via a simple method call do so as well. So let's play this bit again. So if you listen for the violin, now it's quiet because I've taken control of it, so I can now play on it. And of course, that can be used to Mickey Mouse certain effects in the game, or have the gamers actually perform on in-game instruments. And again, going back to what I mentioned about stingers, so we can trigger them and preview them here. And if we change the key, they will always adapt. So that also means that for a composer, you only need to compose these elements once in a single chord, and then you can play them at any point in the soundtrack. Just trigger them and they will adapt to the underlying chord. Now, I think our title was something like from composed music to interactive in 10 minutes or so. So I thought we'd go from here and put it inside of Unity quickly. Let's see here. Let's take this from, just going to change some values. And maybe just for the sake of this demo, I don't know. This quant dial will then also tell the system when it's allowed to trigger these effects. So we have, let's do also a probability on this one. So now we'll export. And we already had one there. Let's remove that first. Loop. This testing here. We're in Unity, and here's our plugin. Now that export has been loaded, and I have set up a simple script here that will check the range of, or the distance between two game objects, one being the player character here, the little one, and the other one being this big giant. And after it has done so, You can remap the range as well. Then we set this control, the macro, with the name given and this normalized value. And we call it something cool. Spelled correctly, something cool. And now as I hit play, the music will then automatically adapt, hopefully. Obviously, you need to tune your parameters so it makes sense musically. Before we leave this scene, you see this keyboard here, and that's playing back the actual notes generated by the system. So everything generates a callback into the game, so you can hook up game events to any event created by the music system. And there is no protection against making ugly mappings in music, so but hopefully you get the idea of what's possible with a system like this. Now, maybe this is a good place to stop for questions, if there are any.
I don't see any questions at the moment. If anybody has any questions, please feel free to ask. One question that I had is, do you have any plans for audio with this, or have you done any experiments with that?
Yeah, so we have experimented, of course, but when you're saying audio, I'm guessing we're talking about essentially instrument separation and then cutting that up to be able to change key and similar things. As far as I know, or what we concluded, is that's still pretty dark arts. Yeah, so I'd love to be able to, you know, take a piece and change the rhythms and the key and stuff of that live. But for now, I don't see that happening. I've done some fun experiments before where actually when Melodyne first came out, it was a big hobby of mine to rearrange particular, you know, choral arrangements into different keys and changing the onsets and stuff. But doing that live, I think we're a bit ways off still.
But
However,
when you get licensing for a track or for a composition, do they give you the stems? How does that work exactly?
I'm not sure I follow now.
So you said so you have licensing rights, right? From
Yes, so actually that's the second big part of our business that we're coming to now. So this is only our interactive system that deals with MIDI-based compositions inside games. But then what we also have, and it's on this web page. Here is our online platform for game developers, where if they perhaps not have a musician on board, they can find pre-composed interactive themes, such as the one you heard. Or for any developer, really, if they want to license commercial music assets, they can do so via our catalog here. And for all of this music, this is not music that we can actually change, or we're not even allowed to change those, because the rights that we have secured prohibits anyone from messing with the masters, essentially. So they're licensed but playing back as original is. However, all of that music we run through an analysis pipeline, which gives us lots of metadata on tempo, chords, key, sections of the song, etc. And with that information, our interactive system can adapt and play on top of this music. So as a demo of that, click here. So here you first hear a familiar piece. This is now in browser. However, what we can do is connect these. So here is a song by Milky Chance, like a club track with a guitar intro. And I'm gonna bring up this interactive music to play together with this.
You make me feel like a reckless child. Just because of you, I get so damn high. I don't even know how to get back down. Only if you pull me back to the ground.
So if we take out the club track, then you can just hear the chords, but being played back through the interactive music system. And we talked about stingers before, and here we can then trigger stingers that will fit to this song instead. Now, the main use case for this is not really to do mashups, but rather to, perhaps in a game you have a particular section of the game where you want to license a commercial track, and licensing music into games thus far has been super, super hard and very, very expensive, and only really reserved for the very big players, AAA studios, where they pay large sums of money to license music that is also licensed on a time basis. So eventually they run out of time for the rights to those tracks in their games, and then also pull those games from the actual stores. So you can see that happen quite often, where a game might sell for 90% off because it's been taken off the store forever because they have no more rights to the music in that game. So that's also something that we hope to solve here. So all of the music that we have available for licensing is also in perpetuity and worldwide, and it allows any developer, regardless of their budget or size, to license music into the games without having to go through all the hoops with lawyers and sync departments and stuff. Now, did you?
No, go ahead.
So the main use case for combining these interactive layers with the commercial tracks, or you could also upload your own linear stereo mixes, and it will also be analyzed and be able to play back with the interactive system. But the main use case for this is probably more to make fun games like, let's see, it's called Music Hustler. Hustler tutorial. Wrong. So here is, if you ever played Tetris Effect, it's like a Tetris game, but set to music. So this is my own version of that using our library. So you'll hear some actually different tracks being played, but on top of that, whenever a piece moves, there's a piano note being generated. And whenever a block drops, you get a stinger, and everything is happening to the beat of the music. everything is more fun with music, of course. And this is actually a project that is available for download on GitHub. And also there's some tutorial info on how to set up a game like this. So we also, obviously I'm quite skilled at using our own tools, but for me, going from Tetris to Music Tetris was less than an hour's work. Obviously it's going to take longer if you've never used the library before, but we're hoping that this is also a way to democratize making these kinds of games where you don't have to build your own, beat systems or beat clocks or similar things just to be able to make a simple music game. Right. Another thing we're also doing with our licensing catalog is allowing developers to also directly sell music to the gamers, meaning if you're making a music game, for instance, it might be very expensive for you as a developer to have a lot of catalog for the gamers to play from. But if they want to, they can, without paying anything upfront, offer millions of tracks from this library directly to the gamers as DLC content. So then you can scale the game up very much and have many more levels of gameplay for their gamers to play. What else? Do we have any questions now? Do you have anything to add, Luke?
No, I mean, because I think we've got, possible programmers watching this, I don't know if it's worth just quickly showing some examples of the API in Unity. I think you kind of already showed that, but just some of those scripts. That might just be one last thing's worth showing.
I can actually show from Unreal here also. So the basic API for controlling music is very simple. It's like this. If you ever used blueprints in Unreal, that's what it looks like. But meta sounds, for instance, is very easy to integrate with. And so what we do with our libraries, we generate a PCM buffer, and then we can push that into whatever audio system is available. So in this case, it's an example how this node in Unreal Metasounds works. So we have our buffer that we get from our render function, and then we just copy that into the output. And that's really all you need in order to make your own nodes in Metasound. So if you have something that can generate sounds, this is really all you need to get that going inside a Metasound node. I'm not sure if, for instance, JUCE already, I would bet someone already has made a JUCE integration for Unreal and Metasound, but if not, that's how you would do it. Here is another example of these callbacks that you can get from the system into Unreal. So here is Metasound for getting note-ons and note-offs. But you can also get them in the main thread to control other aspects of the game with one of these callbacks as well. As for Unity, actually, yes. So the same thing in Unity is on this script here. So all of the scripts in the plugins are also readable and editable by the user if they want to mess with it. However, our proprietary tech is in a binary DLL. But yeah, for Unity, they have something called on-audio filter read. It's not the most performant functions, but if you're not using it on too many objects, it's totally fine. And then we do our render here and pass this data into the audio filter read, and will make it end up in one of the audio sources here. And this can then later be used to spatialize it inside the game world if you want to, or add additional post effects. It's the same setup if you're working with a middleware like Wise or Fmod. We can push that buffer into their input buffer streams, and then you can mix them with the rest of your game audio. So I would have loved to show you more in-depth code also from how the library is set up, but that it's kind of secret sauce. But I'm happy to answer questions on it, of course.
Yeah, have you ever considered this would be a very different this would be very different from other offerings that they have, but have you ever considered writing a JUCE integration for this?
We've actually played with the idea, like when we some years ago went with this route, like how would we get this music into our system? Would we make plugins that would then live inside the DAW where you make your settings, or then what happens if we have different DAWs with different plugin formats, and it would soon be hard to handle, and that's why we decided going with the route to have an external software where you instead reverse engineer the file formats if they're not readable, and then grab everything we need. However, I'd love to have a some JUCE plugins where you would basically get all of these, because these are more or less just MIDI plugins, right? But it would be super nice to be able to have your composition and then quickly just change the key and see what it feels like. And I think some DAWs have similar support for that kind of operations, like Studio One, I think, does that. But also a problem is that we're kind of working with the music in a non-linear way, whereas most DAWs have some kind of linear sense to how things are working. And we do get a lot of requests when showing it off that people would like to use it as a material generator, if you will. And I think like adding support for MIDI out from our tool would not be very hard. There's no plans of yet to make a specific DAW plugin though for these kinds of things. I'd love to do it though, but there are some JUCE bits inside this though, so we're not totally out of the loop there.
Yeah. What
Right.
about just MIDI what about just simple MIDI plugins that break down some of the things that you
Mm.
do? Have you considered that?
I think it's a bandwidth thing mostly for us. We'd love to do it, but we're doing too many things already. I think we're all on the cusp of burnout because we have too many fires that we're dosing and irons in those fires. And now the lights turned off. But yeah, if anybody wants to do these things with us, for us, or collaborate on that, we'd love to hear about it.
Yeah, because I just think that the idea of when I saw your Unreal Fest presentation, the first thing that I thought of was how awesome it is just to be able to riff new ideas off
Yeah.
of. It was like jamming within your own composition, and I thought that was really interesting.
Mm.
Yeah. Well,
Yeah.
we should chat, Josh. The only thing I was going to add, Mr. Salesman, is that you can download the Unity and Unreal SDKs off reactionalmusic.com, and all the documentation and a lot of the deep kind of tutorial videos that Jonas has put together. So that's just there for you to try, and you can download it add tracks, compose your own themes with our composer tool, which you can download for free. And there's like a 30-day free trial. And then there's different payment plans on the pricing page, which you can have a look at.
And to clarify, those pricings are for game developers looking to put that inside a game. If you're just a muso looking to play around with it, you could just do that.
Yep. Yep.
Currently, we support Reaper, Ableton just since last week, Bitwig Studio One, and Cubase via DAW project. But yeah, Reaper is the most stable now if you're a Reaper fan, and who isn't?
There is a question, do you provide instrument samples as well? How did Unity play the Reaper synths?
Right, so we render audio from the actual VSTs that you put inside your session. So there is a contact patch, and yeah, that's being rendered out into a lot of different musical material, and that is then being played back by our own playback engine, and that is running inside Unity as well. So the export from a composer into Unity is this garbage, no, not garbage, but garbled file format. So a huge thing, since we're dealing with music licensing as well, so a huge thing was from the music industry to have to make it as hard as possible to steal their music, because everybody does that these days. But yeah, so that goes for these files as well. And yeah, all of the audio data is then baked into these monoliths, if you will. So you also cannot play back a sound from one exported track inside another. They're sort of like tied to that composition, and that is key for us. That's just as how you as a composer would compose with the VSTs that you have, and then you have a rendered mix. We see it as the same thing, only that it's not linear, I guess.
Cool. I think that's all we have for questions. Is there anything else that we should mention here? How do people get in touch with you?
Just
Go.
go on, Jens. Well, I was just going to say you can go on reactionalmusic.com. I think we put it in the description. Get in touch with me, Luke.Ritchie, RITCHIE at reactionalmusic.com. We'll put our details below, but you can sign up and just get in touch via the website or LinkedIn, or join our Discord server as well. Very welcome to do that.
Yeah, you can find links to all that from within the Reactional platform. Since this is a recorded video, I can then show you this slide, because then people can actually scan that QR code. That only takes you to our website though, but at least that's something.
We'll also be sure to put the details in the video description below as well.
Yeah, that sounds good.
Thanks, Josh.
Yeah. Cool. Thank you so much, Luke and Jonas, for that. That's awesome. I think there are many untapped ideas that are inside that can be used. So I think that's awesome. Cool. I think we'll go ahead and wrap up this meetup. Once again, thank you to sponsors Focusrite and JetBrains for all their support for the meetup. Thank you to the presenters, Jonas, Luke, and Matt. It's great to have you here, and we'll be back in January. So the next date for the meetup is going to be the 14th of January, which is back to our normal slot of the second Tuesday of the month. In the meantime, if you'd like to submit a talk for the audio programmer meetup, you can do so on the audioprogrammer.com/meetups. Also be sure to join our Discord community on the audioprogrammer.com/community. We've just broken 11,000 members there. developers from all around the world talking about all types of cool stuff. So no matter where you may be in your audio programming journey, be sure to come and check us out. And in the meantime, happy holidays, and be sure to have a happy new year. And from us to you, we're going to go ahead and sign off. Have a great one and speak soon.
Thanks, everyone.
Thank you.
Thank you very much.